Hello and welcome to the wonderful world of pipettes. You may already be somewhat familiar with pipettes, micropipettes, and pipettors. However, there's a lot of subtle nuance that goes into using these instruments, so we want to make sure you're fully prepared for your biology skills laboratory. So, let's begin. The first thing you should know about these little beauties is that they're very delicate instruments. They've been calibrated and highly calibrated to work within a specific range of measurements. Outside of that range, or even inside of that range at a level of accuracy beyond what they've been designed to do, they aren't going to get you the correct volume. What do I mean by that? Well, this pipetter that I'm now holding is accurate from 20 to 200 microliters. This pipette is accurate from 10 to 100 microliters. You may notice that they look exactly the same. So, in order to figure out what your pipette is ready for, pre-calibrated for, check the top of the plunger. There should be measurements listed on top of it. So, within this range of 100 to 1000 microliters, you'll notice that there's a lot of intermediate measurements you can make. These are denoted on the side of the pipette in the indicator. The first digit is usually whatever the highest digit is of the highest number. In this case, of the 100 to 1000 microliter pipette, that means it's the thousands place. Below it is the next highest place, the hundreds place. Below that is the third digit, the tens. Most pipettes only have 3 digits. However, below that, there's an array of hash marks, which could be used to make more refined measurements. Or so you might think. These hash marks actually don't have the same level of accuracy as the rest of the pipette, and so you're going to want to avoid using them as much as possible. This pipette, therefore, should be used to make measurements like 870 microliters or 230 microliters. It should not be used to make measurements like 232 or 238 or 473. These are all examples of measurements that will have a small degree of inaccuracy introduced into them just because you're using the wrong pipette. If you need to make highly accurate and precise measurements at those intervals, use a second pipette in addition to your first. Using the 100 to 1000 microliter pipette, as well as a 0.5 to 10 microliter pipette, will allow us to have the highest degree of accuracy and prevent introducing accidental errors into our experimental design. Now, to adjust these settings, you'll notice there's 2 black rings on the side of your pipette. To adjust the first setting, depress the lower ring. You should hear a clicking noise or a release of air. This denotes that your pipette is now ready for adjustments. You can then rotate the upper ring. Rotating this upper ring in either direction will increase or decrease what the pipette has been set for. In this case, I'm lowering it from 730 microliters to 640 microliters. This isn't very difficult, and the ring rotates very easily. So once you set your pipette, you're going to want to raise that lock back up into position to make sure that you don't accidentally change it during experimentation. Now we're ready to use our pipette. You're going to want to make sure you're holding it the right way. So lay your hand along the side of the pipette and wrap your fingers underneath the pipette lip. This gives you a firm hold on the pipette and prevents it from slipping. It also, more importantly, gives your thumb easy access to both the green ejector and the green plunger. You might not be able to see these well in the video, so I'll describe them. The ejector is a smaller button on the side of the pipette. You can place your thumb on it and it does exactly what its name tells you. It ejects the pipette tip. The plunger on top is used to actually pick up and transfer solutions. It has 2 stops. Depressing to the first stop prepares the pipette. You're going to want to do this generally before you insert it into a solution. Depressing to the second stop is something we'll get into later during our demonstration. It's now later. I have my rack of pipette tips and I have my pipette. I'm going to insert my pipette firmly and slowly into the pipette tip. making sure that I've depressed strongly, but not too strongly and not too suddenly. There's a lot of adverbs I'm using here, and the reason is very simple. Using the pipette incorrectly at even this simple stage can cause lasting damage to its calibration mechanism that you really don't want to get into. Believe me. Once you've inserted the pipette tip in, pull your pipette out. If you've inserted the pipette tip too weakly, it'll fall off at this point. Try again. If you've inserted too strongly, you might not know, but you could have caused internal damage to the pipette mechanism itself. But now, our pipette is ready to roll. I've prepared a solution for us of a mysterious blue liquid. I'm not really sure what's in it, but I think it's food coloring. Nothing else in lab is going to look like this. But you might have clear solutions, which could make things a little more difficult for you. Either way, don't hold your solution like I'm doing now. This is only for videos. Leave it on the table where it's steady and secure. Then, taking your pipette, holding it vertically, not horizontally or laterally or upside down. I have no idea why you hold it upside down, but I've seen some weird things in lab, let me tell you. You're going to want to insert it into the solution. Before we do, however, make sure to depress the plunger to the first stop. Doing so prepares the pipette to pick up the solution or volume of liquid. Slowly but surely, insert the pipette into the liquid and then release the plunger slowly. This picks up the liquid, sucking it into the pipette mechanism. Very, very cool. Now, you might feel a little mischievous at this stage, but don't take that urge. Don't give in to shooting the liquid at your friends in lab. Believe it or not, the pipette actually isn't capable of expelling these liquids with sufficient force to hit your friend across the lab bench. And if your instructor sees you, you could be thrown out of lab. I'm not speaking from experience, so far as you know. Now that we have the liquid in our pipette, though, you're going to want to be very careful. You might think you can relax now that you've inserted it vertically and picked it up, but you can't. Keep holding it vertically. Moving it horizontally or laterally or laying the pipette down at this stage could allow liquid to be pulled back into the pipette mechanism. This would not only damage the pipette mechanism, but would contaminate it, rendering all future experimental results inaccurate, potentially without future experimenters even knowing. These pipettes are used throughout our department, so it's very important that you take care of them. When you're ready to transfer your liquid, though, into a new vessel, place the pipette over the vessel, close to the surface of the liquid, but not in the liquid itself. That would introduce more sources of contamination. Then, depress the pipette tip slowly to its first stop. Once depressed to the first stop, you might notice that there's still liquid remaining in the pipette tip. To fully expel the liquid, you now depress the pipette plunger to the second stop. This forces all the liquid out of the pipette, and is an important part of any experiment. You can then release the pipette plunger back to its top position. Don't use pipette tips in more than just one solution. Only use it in one solution before changing the tip to use in other solutions or other liquids. Again, failing to do this could introduce sources of cross-contamination. When you're done with the pipette tip, there should be some sort of container laying around for you to put your used tips in. Simply depress the ejector and it'll release the pipette tip into the basin. We're just about done with our demonstration of the wonderful world of pipettes, so let's recap a few things. First of all, these pipettes are very delicate instruments. They've been calibrated to only work within a specific range, so make sure you stay within that range. If you're unsure what range your pipette is, check the plunger at the top of the pipette. Also, always make sure you're using the pipette vertically. Don't use it horizontally, laterally, or lay it on a lab bench if there's liquid in the pipette tip. All of these are great ways to either ruin your experiment or damage the pipette. On that note, make sure you have a secure grip when using the pipette. Dropping one of these can not only damage your experimental success, but damage the pipette. And one of those cost money. Always make sure that your lab bench is clean and you use proper safety equipment. While pipettes are very accurate mechanisms and can always be used safely, there's always some risk of experimental failure. Because you're working with liquids, you could splash. So, make sure to be prepared. This concludes my demonstration of the wonderful world of pipettes. Thank you so much for watching. Be sure to like and subscribe and check out the other videos on this channel, including how to properly prepare a dilution. See you next time.